this webinar.
Good morning to all. I welcome you all for the webinar on sensor engineering for COVID-19 pandemic. I am very much glad to introduce our chief guest, Dr. Balaji Ganesh, Dean Research Patent Agent, Velamal Engineering College, Chennai. Dr. Ganesh has completed doctoral degree in the area of sensors and instrumentation from National Institute of Technology, Tiruchirappalli, India, in the year 2007. He has been serving as co-coordinator in the TIFAC core in the field of pervasive computing technologies at Velamal Engineering College, Chennai, from April 2007. Currently, he is looking after New Gen IEDC Center as project coordinator. He has been qualified as patent agent and currently pursuing as a patent analyst and IPR consultant. He has received 10 funded research projects from the Department of Science and Technology to the tune of more than rupees 2 crores 50 lakhs and successfully completed 7 projects and 3 projects are being pursued. He was a recipient of Young Scientist under Fast Track Scheme from DST and Career Award for Young Teachers from AICTE. The Department of Science and Technology has appreciated the efforts taken in completing the science and projects on time and also very successfully invited to deliver the lectures in the workshop conducted as a part of India International Science Festival held at Anna University during 13 to 16 October 2017 and also in other occasions. He has filed 4 Indian patents on his own and helping faculty students to register their patents. He has more than 100 international journals and conference proceedings publications. Further, delivered technical guest lectures in more than 75 technical events, including a lecture on optical sensors for environmental monitoring applications, construction procedures at Stony Brook University, New York, USA. I welcome Dr. Balaji Ganesh to address the gathering. Welcome, sir.
Yeah, thank you, Dr. Kavita, and most importantly, Dr. Bokari, and for giving me the opportunity to not only share, also after this particular the topic that you have decided, and I do very sincerely, I should thank you. Why? Because I learned a lot. Even though the sensors and the optical related sensor that we have, fortunately by God's grace, that we were working in our laboratory, but this particular the COVID, the detection procedure, it's really new to me. And so I really spent some quality time in understanding the different chemicals are being used in COVID the detection. Most importantly, even though the similar kind of the construction procedures that we have taken in identifying some other the bacterial cell culture in our laboratory, but this one is a very different one. So, and I have seen a couple of the quality YouTube videos, and I have read very recent the articles, and this is going to be the sharing of the review that I have seen, especially on this particular the topic. So in that the perspective that I should thank, really thank for giving me the opportunity to learn and as well as to share what the thing it is happening in this the particular the pandemic. Why it is very important? Why? Because the countries, especially the South Korea and the Germany, when you are looking at, they have controlled this further spreading of the COVID in their country. How? Because they have had a very great number of the testing procedure, um, uh, very immediately after the spreading of the corona in their country, and they started even in the South Korea. One report it says that every day through their phone booth kind of the thing, they have had 20,000 the testing for each day. Whereas the German, one research article, it was saying that per week they are undergoing 4 lakhs testing. And because the testing is very important, then only that you could identify the disease affected person, and eventually that you could isolate them. This is the one very important thing, because um, before you capture with the disease, then you should understand who are all the people who have been not affected. And in that way, the testing very predominantly considered as a very important. And in this session that we are going to talk about, and we are going to understand what kind of the different the detection procedures are being followed in this the particular the virus detection. Before anything, we need to understand there are two the things have been involved. One is the virus, another one is the disease, right? So this is the exact virus which spread this disease. Of course, it has been referred as the COVID-19. And the topic that we are going to have our discussion in the next 1 hour, we are going to understand very fundamental aspect on optical sensor engineering, because I have seen the students in this particular as a participant, then I need to tell them very fundamental aspect on how they could construct an optical sensor. Because whenever you look at the different kind of for this particular the virus detection, but most of fundamental aspect, it could be construction of a simple optical sensor for the detection of any kind of the analyte. So they have to understand the paradigm or the mechanisms behind in constructing an optical sensor. So with that knowledge, so they could visualize when we are presenting a appropriate kind of the sensing technology for this particular the virus detection, then they could relate it with it. So I just wanted to spend some time to demonstrate the optical sensor engineering, and in which I would take the opportunity to demonstrate one of the sensor that we recently constructed, and even um, one PhD that we have produced on the particular the sensor that we have constructed, and even it is available in the scale of the prototype, um, which would be uh, very the earlier situation. It would be made available as a the commercialized scale. So I would take the opportunity to tell about that particular the sensor and the kind of the way that we have used to detect, to determine the different analyte. And especially on this particular the virus, the strain, there are two kinds of the things that we need to understand. There are two kinds of the possibilities are involved. One is the detection of virus. Another one is the detection of the symptoms, right? So even in the case of the detection of the virus itself, it would be subclassified into two the different the mechanisms. One is the detection of the virus. Another one is the detection of antibodies, which would be the resistance from our body. It has shown against the virus. So today, um, yeah, throughout the world, of course, these two different kind of the detection mechanisms are being followed. One is detection of virus, another one is the detection of antibodies, right? So we are going to have enough discussion on these two kinds of the way, and yeah, after that, very eventually, that we could move on how we could identify by utilizing the different sensor engineering component to detect the symptoms associated with this virus strain. And here and there that we are going to talk about the principle and the operation of the particular the sensor that we are going to understand. And I told you about, and this is the review of the thing that I have gone through. Then I would like to present those review of the prior art that I have gone through. So this would be the first milestone that we would try to spend to understand the characteristics behind any biosensor. Here, the number of the segments that you are seeing. One is the bioreceptor. Then next, it is followed by the transducer, and you have the signal, the amplifying section, and eventually you do see about the microelectronics. Here, this is where your sample, right? It is going to get interact with the bioreceptor module. You can have any kind of the bioreceptor module on the basis of the analyte that you are going to detect. So it could be a enzymes based, it could be a microorganism based, it could be immunoagents, it could be a chemioreceptors, it could be a tissue kind of the bioreceptors. And on the basis of the bioreceptor, then the individual, the transducting element, it would be different. You can have the optical fibers, you can have the electrode kinds of the thing. It could be the potentiometric, it could be amperometric, it could be the volto kind of the thing that you can use, that you can use the kind of the transistor modules, and the thermistor in some other cases it would be very effectively used, and in the other cases the piezoelectric crystal also would be used as the transducer element. So this transducer, of course, which would convert whatever the biochemical values it has been detected on its surface, the corresponding information, it would be converted in the form of the meaningful electrical signals. And those electrical signals, it would be amplified, and the microelectronics part would process further to understand it in the physical values. So this would be the case. Of course, this would be the biomimetic module. This would be the enzyme based or any kind of the activity or the biologically derived activity, and it would make the interaction with the analyte presence in your sample, right? So to further have the very effective understanding on this particular the thing, I would uh, get the help from this animation slide. Again, I have downloaded from the net source. And here these two elements that you are seeing, the transducer and the receptor module, right? Onto the top of the receptor module, the appropriate kind of the membrane, it would be attached. This, the membrane, it would improve the sensing ability. Also, the binding nature of this particular the membrane would help to understand the biochemical values in a very better way. So this would be the components that you would see in any kind of the biosensor, a transducer, which it has been attached with the receptor, and on the top, the surface of your receptor, it would be attached with your membrane. Now, you take your sample, right? You have your sample in the form of the solution in which the both analyte and the solution, it would be present. Whenever the analyte, it would get contact with the receptor module. This receptor module, it would respond to the analyte, and it would create some kind of the disturbances, right? The disturbances, of course, it would be recorded in the form of the electrical signal by means of this transducer, and that would be the recognition the face that you are looking at in any biosensor, and that information, it would be a measurable signal which would be recorded through your the microelectronics, your microcontroller or some other the processing element. Now what would happen? Because my solution, my sample contains both things. It has the analyte that I'm going to measure, as well the other component. What would happen? The other component gets touched or gets in contact with my the receptor module. Let us see. Now the solution, the other component, other than the analyte presence in your the sample, if it gets contact with the receptor module, this receptor won't respond to the other elements other than your analyte elements, and it won't recognize and it won't produce any the measurable signal. Hope you could understand what I am coming to say. Let me explain you with this as with an practical example. For an example, you have the blood sample. In the blood sample, you want to measure the glucose concentration there with your blood sample, right? This is what that you have taken. You have taken the blood sample and you want to measure the amount of glucose concentration present in your blood sample that you have taken. Then what I can do, I need to have a certain biosensor module to understand the concentration of glucose present in my blood sample. Then that time I can have a sample or simple the transducer element as a simple for an instance thermal sensor, right? It could be a thermistor. For an example, in the market that you can find the LM35 kind of the temperature sensor, that I can take that sensor here. Then what I am going to do, this the thermistor or this the thermal sensor, which will record the changes in the temperature in my environment. What I am going to do with this uh, uh, glucose concentration present in your the blood sample, then I need to have a certain the bioreceptor module. Here the bioreceptor module that I can take for an example glucose oxidase. The glucose oxidase is an enzyme, right? That enzyme covalently it would be attached on the top surface of my thermal sensor. This would be the sensing mechanism that I can establish to detect the concentration of glucose present in your blood. In this place, I am going to have my LM35 sensor. On the top surface of LM35 sensor, I am going to covalently, I have entrapped the glucose oxidase. Then, this is the sensor that I am going to use. What would happen? My blood sample contained certain amount of the glucose level. Once the glucose gets in contact with this glucose oxidase, the glucose, it would interact with the glucose oxidase at the resultant of this particular the chemical reaction would produce certain amount of enthalpy changes. So enthalpy changes is nothing but the temperature changes. And the temperature changes, it would be recorded through my thermal sensor, either in terms of the resistance, eventually that I could record it in the form of the voltage. So in the biosensor, to detect the glucose concentration in my blood sample, I can have this kind of the simple arrangement. And now I have the sample of the urine in which that I have to calculate the urea presence. Then what I can do? I can have the same transducting element as the thermal sensor. Instead of glucose oxidase, I can use the urease. The urease is another one enzyme which would interact with the urea concentration present in your urine sample and which would produce certain level of the thermal changes, temperature changes, enthalpy changes. And that enthalpy, it would be recorded through this thermal sensor, and the corresponding resistance changes, it would be recorded very directly proportional to amount of urea presence in your urine sample. Hope you could understand the basic mechanism of any biosensor. It is being used with this kind of the pictorial representation. Right. So this would be the case for the optical fiber sensor. So this is your optical cable, right? So at the end of your optical cable, a certain kind of the chemicals, it would be attached at the end surface of the optical cable at one end. The another end, of course, it would be attached with the optical source and detector. So depends on the reaction it is happening. with a sample solution, the kind of the concentration present in your the analyte in your sample, either on the basis of the property of the sensing mechanism, either it would improve or increase the intensity level, or in some other cases, certain the optical source intensity, it would be absorbed by your the chemical material. Then obviously you would be receiving a minimum level of the optical intensity level. And third, reduction in the optical intensity, it would be directly proportional to the amount of the concentration of the analyte presence in your sample. So these three elements, of course, it records about the fluorescence absorbance. So now in this picture, what you are looking at, this is the sample in which that you have inserted your optoelectronic probe, right? And at the end surface of this optical fiber probe, a sensing membrane it has been attached with, which would react with the analyte present in your sample solution. And this light source, it would excite, whereas this would light source emit, and this would the excited light. It would be recorded by means of other surface, the detector element, right? So this would be the aspect. So in the case of, I was telling about the depends on the fluorescence, the absorbance. So if you want to measure the absorbance property of your certain sample, what you have to do, you can keep your the detector and all those kind of the elements very in the straight line, 180-degree to your the source light, whereas the fluorescence it's the perpendicular to your light source. So in that particular the direction that you can measure the fluorescence. And these two concepts, of course, which would be subjected to certain the leaching property. So the people now, they are using this kind of the lifetime measurement by incorporating the frequency domain and the time domain, the kind of the measurement. So any sensor, of course, the characteristics need to be validated or evaluated, or the basic the sensing characteristics to be evaluated when you are seeing or when you are understanding any kind of the sensor is what is the stability of the sensor. And the stability, when we are talking about, it would be dependent on the physical stability and the photo stability. The physical stability, the strength of attachment of your the sensing, the chemicals and all those kind of the appropriate the biomimetic component attached onto to the surface of your the sensing membrane. So what would happen? Because the sample, it would be in any form. It could be a liquid, or it could be a solid, or it could be the gaseous substance that you have to measure. Then what would happen if you are inserting your the sensing membrane, which would be attached with the appropriate kind of the fluorophores, which would react with the analyte? Then obviously it would leach out into the sample solution. So though you have when it is easily leaching out to the environment, to the sample solution, of course the performance of your sensor would get affected. So at the time of the construction of your sensor itself, then you have to understand what could be the physical stability, what could be the binding nature of your the sensing element onto the basic surface. So it has to be detected, it has to be find out, it has to be determined. So, and the photo stability, because all the kind of the optical sensor that we are going to look out, it would be subjected to illumination of the monochrome and the dichrome, and it's a spectrum of lights, right? So what would happen if the light which would be illuminated on the surface very continuously, which may affect the sensing property or the sensing performance? Then at the time of the construction of your sensor itself, then you have to understand the photo stability of your sensor and the sensitivity. I told you about with the animation slide. So what happened when the other than the solution, it tries to contact with the bioreceptor module. The bioreceptor very intelligently, it won't sense or it won't react whenever the other than analyte gets in the contact on its surface. So that kind of the sensitivity, right? So how sensitive my sensor is, how the minimum changes happening in my sample solution, how effectively it would be recorded by my sensor. I need to understand it and the calibration curve, because all the sensor that we are talking about, of course, it does not have any valid data sheet. Whenever I do have the data sheet after buying from a market, then I can compare the data sheet available in my hand. Then I can understand how the sensor could be the digital form. It could be generated by comparing with the available the data sheet. I'm talking about the calibration curve. So the obviously the calibration curve also it is going to be very important task. Then you have to consider about and the response time, because the COVID, when you read the newspaper, the people are telling in some time after 3 days or after 4 days only, you can receive the test result. In some other cases, in the other news report, they are telling that the scientists they have introduced a certain kind of the new technologies for the detection of the COVID, which would detect the presence of the COVID within the 15 minutes, right? That would be the case. The response time, how much the time my sensor is taking to give away the appropriate the results very positively, and the repeatability. So this would be the case. Even very recently, we could understand that all the sensor that which it has been procured from the China, which would be returned back. Why? Because the sensor it is not responding very well. The sensor it is giving the very false results. Even not only the India that we had an experience of the false result, also all other country who procured the sensor from China, especially for the COVID analysis, they have returned back. Why? Because at the time of my construction, it may produce some kind of the result. And I need to understand with a different repeatable measurement whether my sensor it is behaving in the same way as it behaved earlier. So that also it would be very important. And I told you about the sensor that we have constructed in our laboratory. It's one of the sensors. And in this sensor, the particular the sensor, you can measure the freshness of the meat sample. Earlier in our laboratory, that we were very successful in detecting the bacteria cell colony, especially the E. coli. And after that, we had the sensor for the food fermentation analysis, the milk and the idli batter and the grape juice, all the kind of the thing that we have analyzed its freshness. And after that, we had this type of sensor in our the laboratory, which would be having analysis of the carbon dioxide and the oxygen, right? So because whenever the food, the meat, it gets spoiled, obviously the carbon dioxide level, it would be more. So whenever you are able to measure the CO2, of course, you could detect the freshness of the meat sample. So for that, the component that we used, you do see here an optical source, and you are seeing an optical detector, the photo detector module, whereas the other part, other surface that you do see the LED for the CO2, whereas the CO2, the photodiode that you are seeing here, right? And the sensor film that we have attached at the inner surface of our the container. This sensor, which would be the react with the appropriate the gaseous the substances. For example, this particular the thing, this sensing frame, it would start to react whenever there is a changes in the oxygen level, and this sensing flame it would react and whenever there is a higher level of CO2 presence. I could request the participant please mute your the mic. I could request the participant please mute your mic. Thank you.
Participants, mute your mic. Mute your mic. Vijayalakshmi Kalaipriya. Vijayalakshmi Kalaipriya, mute your mic. Kalaipriya.
Thank you. And
okay, sir, we can continue.
Here you can see the direct the CO2 value in terms of ppm, and you can see the O2 in terms of ppm, and it would display the temperature, and it would advise whether this meat sample it's in the fresh quality or not. And this is the prototype model that we have implemented, and one other prototype model also it is available in our laboratory, and you are most welcome to visit our laboratory to see not only this model, also some other models, especially with the advent of the optical sensing principle. And the photo stability I was mentioning about, this particular the thing, of course, we were recording for the 16 minutes complete the illumination, continuous illumination of with the optical source. And this is the response that we have obtained. The response time that we observed as 30 seconds and the 40 seconds for our the CO2 sensors, and all these values that I could share it with you. And so if you are interested, and this is the thing. So we have taken the sample as chicken, mutton, pork, beef, and fish. So, and we have compared our results with the commercially available the reference carbon dioxide sensor and the reference accent sensor, and we observed the better the results of producing capability of our sensor. And this is the one kind of the result that we have obtained for the fish sample. Here, what you are looking at, you are looking at the O2 values as well as the CO2 value, whereas the red color mark indicates as the time progress, the CO2 level it is very linearly increasing with the time for your the fish sample, whereas the CO2 it is keep on decreasing. Of course, the phenomenon that you are understanding here, whenever the bacterial colony it's increasing, due to its the breathing activity, it breathes out more than the CO2 level. Whereas the oxygen, it consumes the oxygen for its own respiration. That is why in the sample that you are seeing the very decreasing nature of the O2. And now this particular the curve also contains the information about the total bacterial count. So that also it's keep on increasing as the CO2 level increases. So that would be the thing that you can understand with a simple optical sensing principle for any kind of the measurement. And this is what that we could start our the thing. So this particular the picture that I have taken from the Wikipedia, that I was telling you about the COVID, there are two kinds of the detection mechanisms are being followed. One is the amount of virus, another one is the amount of the antibodies. The amount of virus, as the time progresses, you could see the very steep, higher level of presence of the virus. And you can have the number of the detection mechanisms that we are going to talk about and the later. So you can attach. But the other kind of the testing mechanisms, it is the kind of the resistance that we do see from our body. So by detecting the amount of the antibodies present in our the blood, especially the blood, we can detect the presence of the particular the virus. Why? Because it is very basic. Whenever there is a virus, whenever there is an external particular the strain, our body would produce certain kind of the antibodies, right? So whenever you are able to measure, you are able to detect certain kind of the antibodies, which would be very much related to the virus strain that you are looking at. So this is the very perfect way the people are measuring here and there for the COVID. So again, I was taking this particular the zip file from the Wikipedia. You also can have the maximum information on this particular the thing. So with this thing, let me please allow me to present the types of detection. So there are two the different kinds of the mechanisms are being followed. One is the detection of virus, another one is the detection of antibodies. The detection of virus, of course, very predominant the techniques are being followed even from the year 1984. It is a polymerase chain reaction, the kind of the method. In all other news articles or the newspaper that we do see the PCR test, right? So this is nothing but the polymerase chain reaction test. And in addition to that, the people do very oftenly they are using the nucleic acid amplification technique. The other kind of the technique, which would be very much related to this kind of the antibody testing, it is nothing but the antigen kind of the testing. And the detection of antibodies very directly related to the plasma or the serological testing. If you have any more doubts on this, you can ask me the thing so that we can have some kind of the effective the discussion on the point. So this is the PCR, the fundamental aspect. Please allow me. This is fundamental topic, fundamental the technique. Very not directly the COVID analysis. It would be happening through this type of the testing. Why? Because the COVID does not have any DNA, it seems, and it has only the RNA. And what people are doing, because this particular the polymerase chain reaction, it is nothing but kind of the technique to amplify the DNA. After that, they are detecting the amount of very qualitatively they are analyzing the DNA. And whereas the COVID, of course, does not have the DNA, whereas it has the RNA. What they would do, they would reverse transcript the DNA into the RNA into the DNA, and after that they would accommodate this the PCR technique, right? So this in this technique, what we are seeing, we are seeing a cyclic the procedures, which would be governed with the denaturization, annealing, and the elongation. This is the thermal cycling. Thermal cycling, a single genome of your DNA, which would be it would be considered that particular the DNA, it would be and the scaled to the maximum of 10 to the power of 20 level, right? So billions of the DNA would be further and further copied at the end of the each cycle. To perform a single the PCR test, and this particular the cyclic method, they would undergo, it seems, 20 to 40 cycles. So after the 40 cycles, they are detecting the presence of the DNA, right? So, and this particular the process, of course, uh, it would be uh, it would be happen through this the nucleotide and this the DNA primer. The DNA primer and the other one important component that they do use is the DNA polymerase procedure. And this particular the process, the first the process at the level of the temperature 94 degrees Celsius, and the DNA, the primer, it would be segregated into two. And whereas in this the DNA primer, it would be attached, and that particular the mechanism, it would be happening through the annealing process. Immediately after the 94 degrees Celsius, immediately this segregated the DNA, it would be further cooled down with the temperature of the 72 degrees Celsius. And after that, so this elongation mechanism where the tag polymerase procedure, which would be replicated the other the primer of your the functional DNA, what that you have considered the earlier. So this particular the model, of course, which would replicate the original DNA, right? So this would be the cyclic procedure and the denaturization at the higher level temperature. Immediately after that, after segregation of the primers, the strand, and the annealing process, it would happen by utilizing the DNA primer, and with the temperature of a very minimum temperature, then the denaturization process. After that, the elongation, it would happen with the other kind of the temperature, and in that process, the copy of the original DNA, it would be formed. So, and this is what the people are doing in the case of the PCR analysis. That is why the time consumption of this particular the technique, it would be it consumes more and more time, seems. And very recently, this is the because the earlier the PCR test does not have that kind of the quantitative analysis. What people are doing now, especially for the COVID, it seems they do have the reverse transcript the PCR test. I was telling you about, especially for the COVID, you cannot directly include the PCR test, polymerase, the chain reaction test as the PCR test only. It's meant for the DNA amplification procedure, whereas this one is the RNA, and the RNA, it has to be having the DNA polymerase procedure, and that would be the case. And what you are looking at here, the real-time polymerase chain reaction. I was telling you about the PCR. It is for the qualitative analysis. Only it would tell the presence of the virus strain. Whereas the people are looking at some kind of the quantitative analysis. And in the case of the quantitative analysis, the same procedure which would be attached with the fluorophores, right? Then obviously what would happen? In the earlier case, what we have seen in the example, in an example, whenever there is a fluorophore and it would start to react with the corresponding the molecules and the analyte, and it would start to eliminate further. And that higher in intensity level, which would be directly proportional to the amount of the strain presence in your sample. That kind of the thing, it has been included in the existing the polymerase chain reaction, and that method, it is referred as real-time polymerase chain reaction method, right? And that particular the thing, it would happen through one-step and two-step procedure. In the case of one-step procedure, this is the fundamental the thing that you have seen earlier in the earlier picture, and very directly this reverse transcript PCR technique, it would be directly applied. Whereas the other thing, this one is the complementary DNA. This complementary DNA, of course, it would help to convert your the RNA into the corresponding the DNA, and that particular for this is the specific primer. For example, earlier we were telling about the PCR, the tag polymerase, right? So that depends on the virus strain that you have to you want to very quantitatively measure the specific prime that you have to use, and after that you can use the fundamental the PCR that we have seen earlier, and it would produce the quantitative analysis of the virus strain. So that would be the case. That would be the the aspect of being followed worldwide in all other laboratory as a real-time the PCR test. This is the one another technique it is being followed as, and the naming they have given us plasmonic photothermal biosensor. In this, what we are looking at, in the earlier the PCR test, of course, only a qualitative kind of the thing, and after that, real-time PCR test, the quantitative when it has been added with the fluorophores, right? So this would be the advanced scale of the existing the RT, the PCR kind of the technique, which would be happening through this photothermal as well as the surface plasmon resonance kind of the thing. And what you can understand here means the exact the primer that they have used the gold nanoiline as the detecting element or the detector for detecting the presence of the complementary DNA, and this complementary DNA is nothing but our virus strain, right? So this is the exact the schematic representation of the experimental arrangement in this paper they have defined, and the component that we do see here is the so this is a very fundamental the optical component. This was the aperture, the iris, and this would be your polarizer, and this would be the crystal element, and this is your sensing the component. Whereas this would be the light path, and another one, the light, it has been illuminated on the top surface of your the sensing membrane. This is where the surface plasma resonance based your the sensor, it would be happening through. The other kind of the iris model that you have had some kind of the collection element. So, and in this particular the thing, so when you are looking at this particular thing, of course, you would see that very sophisticated the kind of the experimental arrangements it has been made. But when you are looking at the fundamental, the principle, it would be similar to the thing what I have explained you earlier. So this would be the type of the chemicals, the type of the primer that you are using, and of course it would start to react with the virus strain, right? And this would be the very effective as the author, they are claiming that which would be within the 15 minutes time period. So it would produce very accurate results, and they were mentioning about the results and everything. And most importantly, the sample, it requires a very minimum sample as they are claiming. You also can look at this particular the paper, and most important thing is when the PCR, when it has been involved, the PCR is nothing but the amplification of the DNA. So what would happen before you detect the certain virus strain? It has to be amplified, right? So obviously that particular the step, the strategy would require more and more time, as well as the you need to have the very the sophisticated the laboratory, and most importantly the man who uses that kind of the thing, he should be very knowledgeable. But the third, the person, any the laboratory person, if he wants to use this kind of the thing, it would not be possible. But the author in this paper, they are explaining this kind of the arrangement. It could be happening through any kind of the similar kind of the arrangement, and they can detect with a very minimum in sample. They would not require that kind of the amplification and the thermal cycling process and all those kind of the thing. All those things, it would be eradicated by means of this kind of the arrangements, right? And the PCR testing accuracy in one such a paper, they were mentioning about because the PCR, of course, it has considered the different sample they taken from the different the sample, and each and every the sample that you are collecting, of course, the results, it would be very different. For an example, this particular the PCR test produces very insignificant results of 1% when the blood sample it is being used as a testing element. So the limitations of this particular the thing is as the last the tabular column, it was mentioning about the sampling, which sample that you have consider, and most important the sample preparation, because they are taking the sample from one place, and they are collecting the sample, and they are transporting the sample to the laboratory, and when the transport the mechanism, if it is not very effective, the people are claiming that that also would create a lot of the negative results. And that is what they were mentioning about the PCR sample require very specialized handling and the transportation. If it is not, then obviously the negative results, it is very inevitable. And the reagents, because you have seen that it would be dependent on the primer and the tag polymerase and all those kind of the chemicals. Then what would happen if the quality of the particular the reagents are not very standardized? Then obviously the results also would be very poor in nature. Why? Because the different kind of the chemicals, because in any sensing, the sensing components, of course, would have been manufactured by certain people, whereas the chemical components would have been manufactured by the other manufacturer, right? Very obviously. And even the chemicals also would have been manufactured by the different kind of different manufacturers, right? So it depends on the standardization of the particular the product from the manufacturer. The results it would be very different. So the other important thing is the standard PCR methods lack of sensitivity and so lot many number of the false negative results that we are getting. Why? Because especially on the COVID, the people are talking about even at very fewer days, right? The symptoms that even some people they do not have the symptom and the people are telling that they have been suffered with the COVID and that kind of very different kind of the stories are happening even after even one recent notification from the government, even though you spent 14 days in the isolation ward, till then that you are getting the positive the negative results, you do not have the COVID, till then that you have to spend your time in the isolation ward. And this would be directly related to this kind of the PCR, because the PCR even after the virus strain, its effectiveness, it has been over. Even after that period also, some other the PCR test, of course, it tries to detect the presence of the DNA. Why? Because it is very obvious the virus strain would not go even a 1 day or 2 days or 7 days, right? It would be there. So when the kind of the sample they have taken, when it detects the DNA, why? Because again they are multiplying it, they are amplifying it. Then if it is the case, of course, the amplification it would be done from a single the DNA. Even the presence of single DNA in the sample, of course, that also would may show it as the patient is suffering from the DNA, the virus strain. That also is these are all some of the limitations of the scientific community they are finding with the PCR test. The other kind of the virus detection, it would happen to through this antigen. The antigen is it's a kind of the pathogen. So in the pathogen, a certain the spike protein, if it would be attached on the surface of this is your virus strain. On the top of the virus strain, certain the spike protein it would be attached with. The type of the antigen, what they are using as they do claim that they are trying to detect this the spike protein. If there is a appropriate kind of the spike protein presence in your the sample, of course, that's going to be the evidence. The particular the sample it has been accumulated with this the virus strain. Let me tell you once again. This is the red color mark indicates the particular the virus strain. This particular the virus strain, of course, it has had been attached with the other the immune response due to this immune response of this particular the body, and it would be having certain kind of the spike protein. When you are able to detect this spike protein, it creates the evidence that you have and the particular the sample contains this particular the virus strain. This is the particular the mechanism behind this antigen based the thing, and they have taken the sample the nasal passages and from the throat to have this kind of the antigen. You would have seen the number of the antigen kind of the test kit in some other the news articles they are showing. So that would be the event. There are number of the companies they have involved, especially on this particular the antigen kind of the detection mechanisms. And I was telling you about there are two different kind of the way. One is detection of virus. Another one is the detection of the antibodies or serology test, right? So the most of the, the, the detection are being followed with this the antibody test. Even these kind of the kits of very most number we have procured from the China and we have returned back, right? And those the kits kit, of course, it would be on the basis of this antibody test. What does it mean? This is the your the virus strain in which that you are seeing the spike protein, which would be detected through the antigen testing, whereas this is the two the different the antibodies that you are looking at, right? This is the two antibodies that you are looking at. This would be the early response. For an example, they were telling about the 1 week, whereas this one, it's going to be 1 to 3 weeks, right? So if this particular, and especially for this antibody test, they are considering the blood sample, right? And when your blood shows any of these antibodies, right? Then obviously the antibodies is nothing but the resistance that your white blood cell it has showed on the presence of the particular the virus strain. And if the blood, if it contains a certain the amount of the presence of these antibodies, then of course it would be the evidence you have been or the particular the patient has been suffered by the particular the virus strain. Hope you could understand. Earlier, what we were talking about? We were talking about how we could detect the virus either quantitatively or qualitatively by means of the PCR, the plasma resonance, or the kind of the way. Now we are talking about how we could detect the presence of the virus by means of the antibodies produced by your body as a resistance mechanism. Would you please switch off your mic and this is the another one very special kind of the sensor. It has been manufactured by the European scientists through this the Convert project. So please refer by typing it as the Google as the Convert the project. You can download the entire and the report and everything. This is a kind of the bimodal the waveguide interferometer, which would be uses the two modes with a single waveguide. And whenever there is the interferences happening between these two modes, of course, it would be the evidence of the amount of the concentration of your the particular the virus strain or some other elements that you want to measure. So that would be the simple bimodal the waveguide the sensor that the people are using. Um, this is the very another one the important the research it has been happened and published in Nano today 33 in this month. This is a graphene seed and people they have identified the reaction with the graphene with the COVID, right? And it is a kind of the cloth material and which it has been attached with the graphene sheet with the flexible the microelectronics and which would directly react with the COVID and the virus and that would be recorded as in terms of the voltage and they have please visit this particular the paper and try to download and they have used it for because it is there in the cloth and that cloth of course whenever there is the air molecules of course when it has been present with this the coronavirus and of course this particular the graphene seed it would react and it would tell the amount of the virus presence in the particular the environment. So in that way they have identified the hotspot, right? It is a very great the observation it has been happening because there are many other reports are available in the literature. The performance of the graphene, GO, especially in identifying the different virus strain, right? So please try to Google it, the graphene with the COVID. You would find not many kind of the papers, not only this year, also there are the other reports are available 3 years before and 4 years before. And another one important, the PDMS based the 8 electrode system. It has recently invented by the Chinese scientist, and this is the particular the potentiometer kind of the sensor they have developed. And whereas this case for the electrode system, which it has been attached here, whereas this is the Bluetooth kind of the thing, which would directly transfer the information to your mobile phone. And this particular the biosensor, in terms of the voltage, they were able to measure the presence of the COVID. Even you could see the sample it has considered. It's a very minimum sample it would require, and it won't have that kind of the amplification procedure, the PCR kind of the thing. It's a direct recording of your um, presence of your virus strain, the antibodies in your the sample. So this is the thing that I have downloaded from the Nature article. Even every day they are updating this tabular column every day. Even this tabular column that I have taken yesterday, even today morning that I have seen, they have added certain new the kind of the testing mechanisms. So every day they are updating um, this particular the tabular column, the status of testing different methods and its the current status, whether they got the approval from the concerned authority or not, and the kind of the laboratory have been involved in promoting a particular the thing. Even you can see the type of the testing, right? So now you could see the antibody testing, and those kind of the thing that also that you can think about. Please find your time to look at this particular the web page from this the site, so that you also would understand what is really happening with the testing procedure for this particular the virus strain. There are huge in number. There are a number of laboratories, of course, they wanted to contribute in detecting the virus strain. So when we are looking at the biosensor, especially for the, and these are all the performance criteria that it has to be followed. It should be disposable, and it should be accessible and affordable, and easy to use by even not only by the trained user, also by the patients if they want to measure the very dynamic level of the presence of the virus strain. That also should be possible, and it should not require any kind of the equipment. But whenever you do think about the PCR, it requires some kind of the thermal cycler. So unless otherwise you do have the thermal cycler, you cannot perform the PCR analysis. Instead of that, the antibody testing does not require that kind of the equipment to be attached with the sensing the component. So that should be there. In one such application that I was telling about, the bio membrane engineering, right? So in that biomembrane engineering, it is a kind of a potentiometer kind of the thing, which would be directly interfaced with your mobile phone. So any point of time, the user can perform the testing on their own within the period of the 15 minutes, right? Even which would require a very minimum sample. So that also would be the very important criteria to be considered in evaluating the performance of the testing mechanisms. And what we have seen so far, the detection of the virus, there are the other components are there. Even when you are going to any shop, they have the infrared-based thermometer, and they wanted to measure whether you have been suffered by the fever, by abnormal temperature or not. So that's going to be the symptom, right? So similarly for the COVID, there are a number of the manufacturers, they have produced a different kind of the sensing mechanism to understand the symptoms. Uh, it's a very non-contact type, right? So these are all the wearable sensors they wanted to have, and this one is the Indian the startup. Very recently, they have uh, uh, introduced. This is the wearable type of the sensor they have introduced. Whereas this particular the thing, it has the body temperature, heart rate, blood pressure, and sleep, right? And this is the body temperature. Very recently, they have updated along with the existing all kind of the sensor what they had earlier. And this body temperature, again, infrared, the thermal sensor, which would record the temperature in the reading of 77 degree Fahrenheit to 113. So the other kind of the flexible sensor that people they have identified in the throat, and which would record the cough as well as the fever. So when this particular the person which has been suffered then the kind of the half he is producing and the temperature, which would be directly communicated to the mobile phone over the people. And the this particular the American the soldiers, and they wanted to have this kind of the integrated visual augmentation system. They do not want to carry the infrared the thermometer or kind of the thing, whereas it should have some kind of the goggle type of the thing. So whenever they are looking at the person and their the temperature, it has to be recorded. So that would be the case for the integrated visual augmentation system. Please note it down this particular the thing. Please try to Google it, and you can find out more related story on this the American the Army recently, the kind of the projects they wanted to have. Even this particular the startup, they have submitted their project for the call. It has been made by the American Army. So all other stories that you also can hear by browsing it through this integrated visual augmentation system. And the ventilators also, that number of sensor it's being used or it's being required, inspiratory sensing, expiratory sensing, proximal flow sensing, because the accent flow, it is very much important. And whenever the flow sensor to detect the breathing and breathing out, right, the CO2 and the O2, and it is very much important in any kind of the ventilators being and there in the market. So in that particular the way, these are all the sensors are being used, and the inspirator is sensing the airflow rate, and it sends the data to the central computer, whereas the expiratory sensing, it would detect the exhaling behavior. So, so this particular the thing, of course, you need to take care of it, and so the other kind of the sensor which would be recorded, which would be very much required to have your the ventilator system, is the galvanic sensor and the fluorographic sensor. And again, this galvanic sensor, which would be related to the axon cell the monitoring, whereas this fluorographic sensor which would detect whenever there is an axon the depletion range, it is happening in the particular the ventilating system. So if you want to contribute something for the ventilator, you can think about, instead of creating your own ventilator, what kind of the way that the performance of the existing ventilators by adding with this type of the sensor, you can think about it. And this would be the different kind of the sensors are being used. Hot fire gas flow type of the sensor are very directly the accent sensor, right? Then what would happen if you do have the hot wire? So it depends on the axon, the flow and CO2 flow, and the hot wire, it may produce the difference in the resistance level, and that resistance would directly proportional to the gaseous substance that you are looking at. So whereas the axon sensor very directly, it would monitor the axon concentration in the exhaling and inhaling procedure. So the data analytics, that also it would be possible. You can have the 4 different kind of the people, whereas one kind of the person, it's going to be susceptible to your virus strain, whereas the other person very recently he gets an exposed, and the next stage it is going to be the infectious, and the other stage it is going to be required. And for the data analytics, you can have the descriptive analysis, predictive analysis, prescriptive analysis, and automated analysis. In the case of the descriptive analysis, you can think about a particular the environment or the particular the space. You can think about the current and past situation on the basis of that thing. What would happen in the next 1 month or next 2 months? And the predictive analysis also, it would be similar kind of the thing. And prescriptive analysis, what happened earlier, and you have taken certain step, and what kind of the other kind of the mechanism that you can follow it through to further reduce the effect. And the automated analysis, that also thinks there are a lot many stories that I could share. I would respect your the time, so I just move on to the other the data analytics are there in the market. The Alibaba recently introduced the Alibi the health code. which would, in the earlier slide that we have seen, all other the analysis procedure that they have added in this health code, and they have the blue dot, the another one company, and the in silico medicine. Please note it down. These three the data analytics softwares are available in the market. Please look at what they have developed. Even you can visit the GitHub, whereas you can download the databases, the data sets related to the COVID, and you also can train your the algorithm uh, for the effective understanding of this particular the pandemic. And these three sensors have been recently introduced by our the student. And this doorbell, it is infrared type of the sensor. The moment the other person he is standing, any other person, he does not need to press the alarm button. Instead of that, the alarm button itself, it would understand the presence of the human and it would start to ring. This is the ninth standard kit he has developed, and you can look at the other stories, right? So again, the Abhay, so again, the 11th standard student, Sivam Mukherjee, and he has developed this sanitation band. And this particular the band, what they would do means whenever the person he wants to touch an object, one sanitizer, it would be directly spray very autonomously onto the surface. After that, without any worry that you can touch that object. That kind of the band he has developed. And these two brothers, the Karthik and Vinayak Tara, they have developed the two kinds of the thing. One is the portable ventilator made of wood. Another one, sunglasses, which can help maintain a fixed distance between the people. And again, this is the infrared based kind of the thing. Whenever the person who comes very closer to you, this sunglass would make an alarm, right? So that kind of why I have included these four things means because the student participants of this particular the group, of course, they also can think about, because whenever you want to involve any kind of the virus detection, that kind of the thing, you need to have a certain very huge cost to the infrastructure, because you need to have the clean room. You cannot touch the virus strain. You cannot have that kind of the thing. Instead of that, you can think about the contribute in certain kind of the way. Very recently in our laboratory, we started one experiment with because the doctor with whom that we have associated with, he was giving us one assignment as when we are wearing a mask, right? Then obviously whether the mask would prevent the air passage, right? Then he has given us an assignment as to keep the accent sensor inside the mask, then to understand how much amount of the accent, of course, the person he is breathing in, right? And we have the problem statement as we are going to keep one oxygen sensor outside the mask to understand the environmental oxygen level, and inside the mask how much amount of the oxygen it has been reduced inside the mask. And another one sensor, it is the SpO2 analysis, the blood saturation, oxygen saturation rate in the blood. And with these three sensors, we wanted to have a kind of the strategy when the user he is walking, he is jogging, or he is making some kind of the exercise at the time when he is wearing a mask, how much the impact it creates into their body. We wanted to have that kind of the experiment, and we started that kind of the work. What I would recommend you, you also can think about, if you are not able to involve yourself, the virus detection or antibody detection, that kind of the the chemical related work, please contribute yourself these kind of the work, right? So thank you so much. If you have any doubts or if you want to have any remarks, that you can ask me now.
Participants can chat their questions, can post their questions in chat window. Participants can post their questions in chat window. Sir, there was one question earlier. I'll just want to scroll and ask.
Yeah, please.
Sir, is there any correlation of pH level of blood with COVID-19?
Sorry, I do not have an idea about that. So because
How
the
do you
pH,
relate this pH level of blood with the COVID-19? Is there any sensors available to measure the pH levels?
no, I do not have an idea about the pH presence of the pH and the COVID. Sorry. Any other questions? Yeah, Syed Abdul Salam. He was asking about is there any correlation of pH level of blood with COVID? Sorry, I do not have an idea about this.
Hello? Hello? Sir? Sir, are you able to hear? Hello?
Yeah, sir, we are hearing you. Please.
Okay. Sir, are there nanosensors available for the COVID-19?
Of course, there are microfluidic kind of the sensor. The one sensor that I was telling about the convert project, right? So there are
Okay.
number of the microfluidic based sensors the people are have started to invent it. So instead of the nano, you just think about the microfluidic. They are available,
Okay.
but not as the end product level. The laboratory scaled model they have.
Okay, sir.
Yeah.
So, any more questions? So, there is a question from Vidya Rani. Sir, why do you think there is not yet any medicine for this COVID-19? Even uh, just a minute, sir.
Yeah, I am seeing your question.
Even
Why
when
do you
there are
think
so
there
many
is not
technology.
yet any? The medicine, again, it's a curing kind of the thing, right? But the topic that we are talking about is the detection. The medicine, of course, the people are trying from very different perspective. Of course, there are some medicine, but the testing and everything, releasing everything, even the SARS, we do not have the strong medicine. It has been introduced so far from the newspaper article that I'm sharing it with you, because even the WHO, they were telling about it would take minimum 2 years to release the medicine with a strong note for a particular the virus strain. It may take, because the number of the testing procedures, because they would not want to take any risk at all. Because the people are telling about the hydrofluoric and everything, but we do not say, we do not know about its effectiveness.
Okay, sir. Thank you,
Yeah.
sir. So there is another question. How much amount of oxygen is reduced when we are wearing mask?
So that is why I was telling you that very recently one doctor, he has given us an assignment, right? So, and we have started very experimentally how the how much the oxygen it is being reduced when we are wearing mask, and most importantly when we have involved with a different kind of the exercise, right? At that time, the oxygen the requirement in your blood, it should be more, but when we are wearing mask, whether we are preventing it, we have started that particular the work very experimentally now. So I do not have any experimental results on that. Even I have Google it. There are number of the papers are available, but none of the paper they have had. They were telling about the very strong evidence that this is the reduction in oxygen because of wearing of mask. I do not have the data.
Okay, so I think there are no more questions. Can you just type your email ID so that these participants can mail their questions?
My email ID is now you are seeing the contact details, right?
Okay.
Yeah. So this is my contact details. So the
Okay.
abganesh@vlml.edu.in
Yeah,
and
yeah.
WhatsApp number 98427919259.
Yes, sir. Thank you, sir.
Yeah.
So
Thank you.
the session was very informative and was very useful. We got many details as such, and we could able to see the setup, that is the sensor setup also, the analysis for COVID-19. So we could end up this session, sir, now. Thank you very much,
Yeah.
sir.
Thank you. Thank you.
Devi?
Sir, vote of thanks by Professor Salam, sir.
Good afternoon, all. First of all, I thank our management for providing such forum to conduct this online webinar. Next, I wholeheartedly thank our speaker, Dr. Balaji Ganesh, Dean Research and Development, Qualified Patent Agent, Velamal Engineering College, Chennai, for accepting our invitation and delivered his much valuable information speech amidst his very busy schedule. Thank you, sir. I thank our principal madam for her moral support and guidance in all our efforts. Thank you, ma'am. My sincere thanks to our HOD sir for the steps taken and follow-up he had done to conduct this webinar. Thank you, sir. I thank all the faculties of ECE department who are the pillars behind the successful conduction of this webinar. Thank you, professors. Last but not least, I thank all the participants for joining with us for this webinar. Thank you all once again. Thank you.